Welcome to this lecture. In the last lecture, we had started to discuss about the decorator pattern. We had said that the decorator pattern is a very powerful pattern. If we use it, we can add responsibilities to individual objects dynamically, which is in contrast to static addition of methods or responsibilities to classes through inheritance. We had discussed about the basic structure of the decorator pattern, the class structure, with the help of an example. Now, let us recollect the class structure that we had discussed. If you remember, the client interacts with the outermost decorator. Both the concrete component and the decorator, they inherit from an abstract component or they implement a interface, the same interface component, or they are derived from the same abstract class component, and therefore, they have the same methods. For example, operation is inherited by both the concrete component and the decorator. The client cannot distinguish whether it is dealing with the concrete component or the decorator, and therefore, the decorators once added seamlessly sit on the concrete component and the client does not even know that it is dealing with something different. There can be different types of decorators, but again they are derived from the same decorator class and therefore, they have the same methods. Of course, they can add additional methods as well. For the methods that are defined in the concrete component, the decorator just forwards it to the concrete component. And just see here that this is aggregation and there is one, the cardinality is 1. That means, for a given component, we can add only one decorator at a time, and each decorator adds additional functionality. The client interacts with the outermost decorator. The class diagram is simple if we understand it, but it is a very powerful mechanism. Let us try to look at some examples and see the advantage of the decorator pattern. If we know this pattern well, we will have enough opportunity to apply this and make our application elegant and sophisticated. The decorator, as we have been discussing, we can add responsibilities at runtime, that is dynamically we can add responsibilities and even remove responsibilities. Even though in the examples that we have discussed, we have only added responsibilities, but then it is also possible to remove the responsibility by just destroying one of the decorators. Compared to adding responsibility through inheritance, use of decorator avoids subclass explosion. We had seen through an example that if we can add responsibility to entire classes and for some specific applications, we might have hundreds of subclasses. It becomes extremely confusing. for maintenance, for development, the programmer would have to look up, and not only that, these are permanently bound, the responsibilities are permanently bound, and therefore, there will be several responsibilities of a class which the programmer does not need, but still those methods will be there just complicating the program. We can recursively nest multiple responsibilities. As far as the implementation is concerned, the decorator has the same interface as the concrete component, and each decorator should add only one or two small methods. It should not be a heavyweight class. The decorator should not have drastically different and large responsibilities. If that is the case, we need very different algorithms, very different responsibilities, then the strategy pattern would be more meaningful rather than using the decorator. Let us look at some examples of uses of the decorator pattern. One of the areas we had remarked where decorator pattern is used profusely is in GUI development, graphical user interface development, and also in the development of input output streams, the IO streams. Let us first look at the GUI part. Typical GUI components do not have scroll bars. Now, in some situations we need scroll bars. For example, we have lot of text and all are not visible. We would like to have scroll bars so that the user can scroll up and down and look at the text. In Java, JScrollPen, the JScrollPen component or the widget is a container with scroll bars, and if we add any component to the JScrollPen, then that becomes scrollable. And we will see that this is a direct application of the decorator pattern. Now, let us look at this example. Any GUI component, the JScrollPen can decorate it. Let us say we create a text area with 20 rows and 30 columns. So, we create new J text area 20, 30, and area is the reference to that, and then we create a scroll pen and we give area as the argument to it. So, this is the constructor for the JScrollPen, and it takes area as the argument, and as a result the scroll pen will contain the area. That is, the text area which was created 20 columns and rows, 30 rows, to which a scroll pen will get attached, and then we can attach this to the content pen by the same mechanism. So, just see here that there are two decorators which have got added here. This is the scrollable client, this is the text, this entire thing is the text, but then our window cannot display everything. This is the viewport, only a small part of the text is visible. Now, for the client to look at different parts of the text, we need to give the scroll pans, and that is what we have done. The scroll pan, the vertical and the horizontal scroll pans get attached here, and now we can scroll and look at different parts of the text. Another decorator is the Java border. Scroll pan is a decorator, and in GUI another popular decorator is a Java border. Any J component we can attach border to that or decorate with border. If we tell in more technical terms, we can say that a component can be decorated with a border, and we are implying that we are using the decorator pattern. The borders themselves are not components, but then they know how to draw the edges of the Java swing components. The borders not only draw a line and fancy edges around the Java swing component, but also the borders provide title to a component and also some empty space around the component and also some basic behavior. The basic behavior can be to minimize, to maximize, to fill the entire screen, make it into an icon by minimizing, to delete by pressing a cross and so on. These are some of the basic behavior that the border can give to a component. Now, let us look at how to attach a border and a scroll bar. We want to attach two decorators. This is the original text, and then we want to attach a scroll bar and we want to attach a border. So, there will be two decorators. We want to first decorate the original text with a scroll bar and then we will attach or decorate with a border. So, finally, it would appear like this. There is a scroll pan and then there is a border. If we see in terms of the class relations, the border is associated with the scroll bar and the scroll bar is associated with the text, or let us say in the terms of object relations, we have the border which has a link to the scroll bar and the scroll bar has a link to the text. And the terminology that we use, the original text we call this as the decorated and the scroll bar and the border are the decorators. And the client always interacts with the outermost decorator. Now, let us see the code, the Java code. We have a text view, we create a text view and then we attach a scroll decorator, that is a scroll bar to the text view, and then we attach the border. So, we have done it. We have created the text view and given that as argument to the scroll decorator, and then the entire thing is a argument to the border decorator. You might have done such programming in Java Swing, and if you know the decorator pattern, then you will understand why you are doing like this. And also the names given in the Java Swing components: border decorator, scroll decorator, which hints that these are the direct use of the decorator pattern in the Java Swing based user interface development. And then if we say a widget dot draw, the draw method of the outermost component, that is border decorator, will be invoked, and that in turn will pass the request to the scroll decorator. The scroll decorator will pass that into the text view decorator. Those aspects which they can handle themselves, they will not pass it. For example, scroll related a widget dot scroll or something like that, that will be handled by the scroll decorator, not be forwarded to text view. But otherwise, the border decorator will forward the request to the scroll decorator, which will in turn forward the request to the text view. Now, let us look at an example of the Java I/O stream. You might have done some programming using Java I/O, the Java input output, and if you look at this code now, it will appear familiar, and then you will realize that the code that you have been writing are actually the decorator pattern that has been used in the Java I/O stream. Just look at here, we have created a file stream, a basic raw file stream here, by giving the name of the file, and then the ASCII 7 stream interprets the raw file stream bytes as ASCII characters, and then the compressing stream is a decorator which compresses it. So, if you put string hello world, it will be converted to a file stream, but first it will be compressed the ASCII 7 stream and then the file written to the file. Now, let us say we understand the decorator pattern, that this is a clear example of a decorator pattern, and after having done this, how will the class diagram look like? If we have defined the classes ASCII stream, compressing stream and the file stream, how are these classes interconnected or structured? If we know the decorator pattern, can we draw the class diagram? Please try to draw the class diagram, and we will just display that in the next slide. Here text view is the basic component. The text view is the basic or the concrete component on which we can add various types of decorators. Both the text view and the decorator are derived from the visual component, and there are various types of decorator. One is the scroll decorator and the other is the border decorator. The scroll decorator and border decorator also have the same interface as the visual component draw, but they add additional capabilities. For example, scroll to and draw border. For those methods which they can complete the processing requirement, they just do it, do not pass it to the internal, the object they are holding internally, but for other ones like draw, they would pass it to the object that is inside. So, you can have a text view to which we can either add a scroll bar and then a border, or we can add a border and then a scroll bar and so on. That will be decided in the runtime. And also we can add the border decorator twice. For example, on the text view we can add the border, and then we can add the scroll bar, and finally we can add another border. These are all possible. So far in our discussion on the decorator pattern, we have said that the decorator pattern gives a convenient option to add responsibilities to object, which is advantageous in many situations, in contrast to adding capabilities to an entire class through inheritance. Many times the programmers get prompted or attracted to use inheritance because inheritance is simple to use, appealing, and for everything they use inheritance. But then if we use inheritance to add responsibilities, that would lead to an explosion of classes. For example, if we try to do this border example, that we want to the basic text view, and then we derive a class text view with border, and then text view with border and scroll bar, text view with just scroll bar, and so on. Then we need many more classes. Just to draw that so that it is clear, let us say we have text view class, and we need another component. If we are using inheritance, then we will have text view with border. Now, let us say we want text view with border and scroll bar, and we want only text view with scroll bar, and we want text view with scroll bar and then border, and so on. Text view with two borders, and so on. There will be lot of classes, and if we use the decorator pattern, we can add responsibilities to objects whenever necessary. And also, if we have another basic component like streamed video view, in addition to text view, we also want to decorate a streamed video view, then that would be twice the number of classes here. We will have the streamed video view, and then all these classes will be there. But then if we use a decorator pattern, then we just need one extra class. Here it is doubling of the classes if we add a new basic object, but then if we use a decorator pattern, there is just incremental increase of only one class. Please try to draw the diagram where we have two basic components, the text view and the streamed video view, and then we can add the border or a scroll bar to either of these. Please try to draw this, and we will show the solution here. Okay, this is the solution. So, we had the text view. Okay, we will write here that we have the text view, and we can have one more class here, basic class, the streamed video view. So, just add one more class here, the basic class, and these are the decorators can be applied to the streamed video view as well. But do the decorators have some disadvantages? If we use the decorators recklessly, we add too many decorators, the code becomes difficult to understand. Like Java IO streams, we can add many decorators. If we look at the Java book and find out how many decorators are there in the Java IO streams, we will find that 60 odd decorators. Now, just imagine that we add these 60 odd decorators to a basic stream in various ways. Then the person trying to understand the code would be very hard pressed, because these are attached dynamically. You can't just look at the code and then decide, because you can even attach this dynamically. So, we need to look at the runtime behavior, becomes very difficult. The solutions become complex, and if we have too many decorators, we might use a factory class which will help us create several decorators. It will be manageable if we use a factory class to add lot of decorators, but as long as we add only a handful of decorators, 3, 4, 5 and so on, use of the decorator pattern provides us sophistication, flexibility, and our application can become elegant. We are almost at the end of this lecture. We will stop here and continue from this point in the next lecture. Thank you.